Now we're going to review all of the different types of factoring that we've learned so far, and I created a sheet for you so you can see all of the different types and an example of each. The first thing you want to look for every time you factor is whether or not it has a GCF. You always want to factor out the common factor first before you look for the other types of factoring. So our first example, we have a common factor of 3x, so we factored that out. Second, look for t-chart. If it's a trinomial, it's got an x squared piece, an x piece, and a constant, what multiplies to the constant and adds to the middle term. We also learned how to factor difference of squares. You can add in the 0x term and turn it into a t-chart factoring. Perfect squares is a special type of t-chart factoring. You can simplify it to the binomial squared. And then factor completely is when it has a GCF, and you can keep factoring usually with a t-chart. So starting off our review, again, always look for a GCF first. Our first example, both terms have an x, so I can factor that x out as a GCF, leaving me with x minus 8. What's inside the parentheses does not have an x squared term, so we can't factor it further. Taking a look at our second example, does it have a GCF? There is a 5 on both terms, so we can factor out our 5, leaving us with x squared minus 1 when we divide the 5 out. Looking at what's in the parentheses, it does have an x squared term, so we can think about trying to set this up as a t-chart. What multiplies to a negative 1 and adds to 0 because we have 0 middle term. 1 times 1 gives us 1. Make one of the values negative when you're multiplying to a negative. Negative 1 plus 1 gives us 0. So this is that difference of squares. Keep your GCF of 5, factor it into x minus 1 times x plus 1. Next example, all three terms have a common factor of 2, so I'm going to start by dividing out my 2, leaving me with x squared minus 5x minus 14. What's inside has an x squared term and looks like a t-chart. What multiplies to a negative 14 and adds to a negative 5. Two numbers that multiply to 14 are 7 times 2. We need to multiply to a negative, so we should have one negative value, and we're adding to a negative, so the larger value should be negative. Negative 7 plus 2 is negative 5, so we get y equals GCF of 2, x minus 7 times x plus 2. Our next example, the x squared term has a negative sign in front of it, so we need to factor that out, leaving us with x squared minus 15x plus 56. Be sure to change the sign on everything that's left. Now we can set up our t-chart. What multiplies to 56 and adds to a negative 15. Two numbers that multiply to 56 are 7 and 8, but we're multiplying to a positive and adding to a negative, so both of our numbers should be negative. Negative 7 plus negative 8 is negative 15, so that checks out. Factoring this by keeping that GCF of negative 1. And we have x minus 7 times x minus 8. Last set of examples, we have a GCF of negative 3. Dividing that out of each of our terms, we have x squared plus 11x minus 12. So we're looking for numbers that multiply to a negative 12 and add to a positive 11. Pair of numbers that most students don't think of, 1 times 12. In order to multiply to a negative, we need one value negative, and we're adding to a positive, so the smaller number needs to be negative. So negative 1 plus 12 does give us that positive 11. So we keep the GCF of negative 3, and we get x minus 1 times x plus 12. Last example, We have no common factor. Our first term doesn't have a number, and our last term doesn't have a variable, so we're just going to set up our t-chart. What multiplies to a positive 36 and adds to a positive 12? Numbers that multiply to 36 are 6 times 6, and 6 plus 6 gives us 12. So this is an example of our perfect square trinomial. We would have x plus 6 times x plus 6, so we can shortcut that and have x plus 6 squared. And here are 2 U-Try problems. Please make sure that you have them completely factored before you come to class tomorrow so we can discuss our process.